So, good morning, everyone. It's good to see so many of you. And indeed, I was the founding president of the Free Software Foundation Europe, have been running that until 2009. And from 2010 onward, I was one of the people starting and now managing Kolab Systems as the company that drives excellence in 100% free software collaboration. We felt back then that this was one of the most important tasks to tackle, and it is in fact interesting, and I shared this also with Carlo Piana, with whom I've worked for many, many years, including at the FSFE. Very interesting to have this level of dialogue now with Microsoft, which I take as a good sign. I believe that change may in fact just be happening. It's been due for a while, and of course we will see the actions as we move forward, but I do hear the message and I'm very glad to hear it. So let me introduce Kolab Systems. So Kolab Systems is a Swiss company. We are a share held business based in Zurich, Switzerland, so this is home. And this is in fact where we have incorporated our headquarters with the entire senior team. We also have for Kolab an office in Berlin. We are part of a larger company group and story. The company group across everything has about 250 employees. One side of the company group is focusing on the whole Qt development side. So they've been working on the cross-platform interoperability, embedded devices, visual, UI application layer a lot. The other side is Dreamlab Technologies, a security business that's been focused on penetration testing, measurable security through initiatives such as the EasyCom, which creates the OSTEM, the open source security testing methodology manual, for which they actually train the auditors. And they bring in some security expertise that we use for our own study of how can we make the system as secure as it can possibly be. Kolab as a company has about 20 people right now. So we're still not gigantic, but have been growing rapidly over the past years. And Kolab as a story is actually much, much older than the company itself. So Kolab started in 2002, 2003, when the German Federal Office for IT Security had the requirement that they wanted something like Exchange, right? A groupware system with messaging and calendaring and all these kind of things, but they wanted it 100% free software, 100% open source, and based on open standards. Even back then, interoperability for them was an essential part because they were still running Windows desktops. Today, they're, I think, fully on Linux at the moment. But back then, interoperability was already part of that story. Why did the BSI do that? Very simple. They wanted that because this was the only thing that they felt they could trust. They wanted full auditability all the way down. They wanted to be able to see everything and touch everything where they feel they needed to touch it. There was nothing in the market that existed at the time, right? There was no solution that met those requirements for the BSI. And so they, made a call, they tendered it out, and a bunch of companies won that tender and built what would then become Kolab. I mean, it had a different name before, and then it started out as Kolab version 1, version 2. It's been deployed at the BSI for that entire time. And so the background of Kolab has been very much on the create a collaboration solution that gives you more control, more security, and more interoperability from the start. And then in 2010, we actually decided to take it to another level. I mean, Kolab as a technology had achieved many of its goals. At the same time, we saw Kolab as a product not really being taken up by the market in the way it should be. The reason behind that was very much that the companies that had initially won that tender, I mean, tenders are project-based, right? So they're project-based businesses. And as we all know, or at least those of us who've dealt with this, project-based business and product-based business are very fundamentally different. They work to completely different ways of resource allocation and priorities, and you don't have that constant product-centric attention on a solution such as Kolab if you're running it as a project-based thing. And that was exactly why Kolab had not managed to penetrate as much as it could have and should have. So in 2010, we started Kolab Systems in Switzerland for all the benefits that Swiss legislation gives us, and brought a completely new team on board. So a new architect, new designers, new developers, and refactored the entire solution, in particular on the server side, for the next 2 years roughly, until we have Kolab Generation 3, which is what we now have and which is what I can also talk to technically. If you're interested in the legacy, we can talk about that later, but effectively, this is a natural iteration based on the same architectural principles, and always from a idea of, if we cannot do this in a way without compromising the security of the system or the way in which we handle permissions and things like that, we don't do it. We need to find ways to always have, you know, the least possible privileges as far out as possible, and then scale down and actually fail in security nicely as well. So we have a graceful, slow degradation of security, because we all know 100% security doesn't exist. It's impossible, especially when you need to be connected to the internet, which, you know, for a group or a system kind of is essential. I mean, we need to exchange messages. So you need to have a way to slowly fail on security. And that has been part of our systemic design of the architecture from the start. So what does Kolab do? Kolab, in its standard edition right now, so that's the version 3.4 community edition, or enterprise 14, gives you the full range of asynchronous communication, I would say. So you have your email, right? Obviously, I mean, email, often declared dead, keeps growing regardless. Business email is growing day by day. There's billions of mails sent, and that medium has some unique benefits over other forms of communication that I don't think it's going to go away. I think it's only getting supplemented. So therefore, doing email and doing it well is and will remain an essential part of any solution in this field. Calendaring, of course, right? This whole scheduling area, we have a very complete solution for that, including a very, very complex and complete resource management in there. So we have scenarios including non-unique resources, right? You don't care which beamer you get, you just need one of them. Or you just need a conference room, but you don't necessarily need a specific one. So you can get the one that is free right now, but you shouldn't get the one next to the boss, because that one can only be approved by the secretary of the boss, right? She guards that room. So she is the resource manager for that resource and can then approve or not your request for a room there. All of this is fully implemented, and you can model all of these scenarios in Kolab today. Contacts, you need to know who to communicate with, right? All of that, of course, pretty standard. We have a file cloud module in there as well, that is deeply integrated with the rest of the story. So, and our file module effectively is a layer in the server that gives us modular dialogues that can be integrated into any web application, which is done this way because we wanted to be able to say, attach something from my file cloud or save something to my file cloud in the email dialog, right? We had that feature before Google. And I'm actually very proud of that, by the way. So we have that as a generic middleware layer that everyone can use. And in fact, we've even pushed it out as its own free software project. So everyone is welcome and encouraged to use that and thus add that level of file cloud functionality to their own applications. And in the back end, what you can do is then actually hook up any kind of file storage we store all our information in IMAP for a variety of reasons that I'm happy to go into in the architecture. But you can also hook up other systems where you just need to implement a set of API calls. We have cfile as a standard component in there right now. You can use anything else, really. So that makes it very easy to have your file integration into your web application, and you have a web dev connectivity at the moment in order to then access those files. We have a very strong task module as well, including a full and deep delegation. So you have the capability of not only sharing things, in fact, Kolab in the architecture can share every single object type with users or groups of users in any kind of access model that you want. So we have a full mesh of sharing any of these types in the same way, consistently for the user across your system, so everything is shareable and it is in fact consistent. Tasks can be delegated as well, so not just work through shared folders, so you can actually have the email delegation workflow. We have the full mesh of mail to calendar, mail to task. You send your task by email to delegate it. You can send an email, a calendar as an email to someone else to say, look, this event is interesting to us. The entire mesh is very complete. We've done that deliberately, so we would solve that problem and solve it well. We have seen a lot of incomplete solutions of this whole problem space, and we felt, wouldn't it be nice to actually have this base functionality solid and robust and reliable and actually working well. And we have added notes as well, which in fact you can attach, for instance, to emails, right? So you can just get your email, you can attach a note to it, and then the note and the mail remain semantically linked in the system. So from the note, I can also I have a link where I can click back onto my mail, no matter where the mail now lives. So I can actually move my mail around, and I still find it from the note that I have attached to the mail. We have that functionality in the database level across all object types. We can semantically link any object with any other object, or multitudes of them, which gives us the capability to actually create a knowledge base, right? You can actually map a knowledge base in the system. The only question is where you have the interfaces to actually interact with it. We have that in the calendar dialog, we have it in the mail dialog and the task dialog, to link with notes and things like that. You can create project-specific dialogues very, very easily because the web interface is actually extremely versatile and extensible. In fact, let me talk a little bit about our client story. So, all platform interoperability, right? You have a bright, wide world where people bring all sorts of things to work and expect it to work. You have a bring your own device world where people just bring their mobile and they expect to be able to hook it up. They have tablets, they have laptops, they have desktops, and heck, the desktop also declared dead, also doesn't really die, and it won't, I believe. It's a form factor that for some tasks is just really, really useful. Therefore, that form factor, yes, it will focus a little bit more on certain application types, right? Having a proper keyboard and a big screen when you work on a large document is really advantageous. I don't want to do that on a tablet. I don't think a tablet as a form factor will be able to allow me as efficiently. So it's going to professionalize more, but it's not going away. Other object types are maybe supplementing this, right? You have a supplementary view where you get more ways of accessing the same data, and you want to display the data in the actual way that makes sense for that system or that form factor, whatever you're interacting with, but you're not replacing one by the other. They're just becoming alternate means of access. So that's exactly where we're headed with the system, right? We are, in fact, expecting our users to come from any platform, including on Microsoft Windows, but also on Linux, on Mac, and have their tablets, their mobile phones, their phablets, whatever, and want to work with them. So we integrate against mobile with ActiveSync, actually, because ActiveSync has evolved as the de facto default standard for these kind of things. Most manufacturers support it. The best support very clearly is found in the Apple world, right? The iOS devices, so the iPad and the iPhone, are the ones that have the most complete support. But I mean, BlackBerry has support, Android has some support, not as good. So on Android, for instance, CalDAV and CartDAV are typically the more common choices because of the platform limitation of your device. But what you can do with all these protocols is pick the one that works best for you on that particular device, on that particular platform, and then natively integrate your data stream from the server into that device. Because I want to be able to use my favorite calendar app. I want to be able to somehow link this into my notification system on the device and so on and so forth. I don't want that in a separate box, right? I want to actually have that natively integrate and fully be supplementary to all my other data sources that I might have. I want this to become natural on the device. So that's what we do. For Mac OS, otherwise, so if you have your MacBooks, whatever, CalDAV, CartDAV, in our experience, are very solid choices for them, and we support them extremely well. We have some Mac specialized partners who have evaluated many solutions in the market and found Kolab to be the one that supports Mac the best, including their location-aware services and stuff like that. So you can model all of that in Kolab, in fact. And so we have the full support for that platform. And of course, Windows, right? Windows is there. I mean, it's clearly not going away. So it's going to remain a reality and a popular operating system deployed across many platforms for quite a while to come. Therefore, it needs to be supported. We support that in two ways right now. And we're going to have a third way very soon. So one is, of course, through applications such as Mozilla Thunderbird and so on and so forth, which run on Windows, right? So that's a way to work on that platform, but then A, the technological future of Thunderbird, not quite clear for quite some time, and B, we internally would consider it groupware light, right? It has some of the functionality, it has nowhere near all of the functionality. Now, if you want all of the functionality, there is an application in the free software realm that we have been very actively engaged with. In fact, Jonathan mentioned it yesterday, which is KDE PIM, Contact. Right? It's the KDE productivity application on the desktop. Now, the Kolab Systems Company Group, in particular, KDAB, which is the company that specializes on the Qt and C++ development cross platforms, along with Blue Systems, along with Red Hat and others, have been working on that stack for a very long time. We've contributed massively to it over the years. And the reason we do that is we want an application that can run on all platforms. And the Qt technology stack actually gives you that, right? Qt is one of the very few base technologies that allows you to go on all platforms. You can go on Linux natively, which is fantastic, right? So you have your GNU Linux PCs and you run on all of them, fantastic, good. But you can also go on Windows. You can go on Mac, you can go on tablets, you can go anywhere. You can go embedded, you can have your fridge become a full groupware application. That is the option that this technology base gives you. Now, it's a very complex application, and I mean, whoever has ever touched Outlook will know that that's also a very big beast, right? It's a massive application. And since that application, Contact, also has a similar scope in terms of the functions it can match. In fact, it's more or less par on par in terms of function space. It's a huge application. And yes, so that is a massive task that has taken quite a bit of resource over the years. And it's only now coming to a point that Contact is approaching something that we would call product readiness. We, as a business, have actually focused on the server first because we had to sort that out first. And are now dedicating a substantial amount of resource to Contact, and have in fact one of our first big adopters for that, which is the city of Munich, right, which is planning to roll this out in its entire desktop infrastructure. And while Munich is often cited as the place where everything is Linux, that's not quite true, right? They still have a substantial number of Windows desktops in the city as well, and Contact is the application they want to use across Windows and Linux, across all the platforms that they have. So it's a one application, all platform story there. And of course our web interface. I mean, the Kolab web interface is, I mean, I'm not totally impartial, but I would clearly say it is the most attractive web interface, especially if you look into the open source realm in this field. In fact, the mail component of our web interface is installed on over 500,000 sites worldwide and known as Roundcube. And in fact, it's been what Sentil and many others have been using for many, many years as well. I mean, that's actually just the mail component of what we see as the Kolab web application. So Kolab as a system, the server side in particular, was deliberately designed to scale to millions and in theory even billions, I guess, of users. We built it so that you can scale it all the way up, but you can scale it all the way down as well. We have users running it on a Raspberry Pi. So yeah, they have their entire groupware system running on a Raspberry Pi, and yes, it cannot serve 100 users. That's obvious, right? I mean, the resource needs to be there. But it works. It actually works, and they can run their 1, 2, 3 person household on it and share their calendars with each other. Why have we built it for that range of scalability? It's very simple. We do not believe that the market or customers in general, users, already know the final answer to what their cloud strategy will be. We believe that people will want to adjust just how far or how close they want to keep that information. They will want to be able to decide that and also change that decision. They want to be able to say, all right, you know, I want to get all the scalability and cost benefits of running this in a big public cloud, or yeah, I really want to take this a little bit closer because this is my central business intelligence. You know, I don't feel good about having that all the way out there, so I want to run this maybe even on-premise again. And they should be free to make that choice, we believe. We believe that they should be able to make that choice, which is exactly why we built the system in the way we did. And we actually have support options for all of these channels. So you can make your decision and you can change your decision with support. You don't lose any of the professional support that surrounds this. I mean, the entire application that we built is 100% free software. It is 100% open source. It's 100% open standards. We do nothing but. In all versions, including our enterprise version, right? So we have a business model where we provide a quality assured stream to customers, but that comes as 100% free software. We never, ever add a proprietary license. What we do is we add support. We add the people behind the technology. We add the third level who actually know what they're doing, and we de-risk the deployment for the customer. That's what we do. Because the vision that we see, or where we think this is headed, is really that we won't have that one cloud that will do everything, right? I mean, yes, there will be some very large clouds. I mean, obviously Microsoft and Amazon and Google, they're all going to be running massive clouds, right? And yes, those will have their users, clearly. At the same time, we believe that the whole ecosystem really calls for more of a mesh of interactive clouds that talk to each other through open standards, that interoperate, but allow the user choice and freedom to go where they feel they should be. And that decision can also change. So we believe we need a technology that enables us to do that. And that's why we're building Kolab to be that technology. So on the server side, we would actually describe Kolab as a swarm of microservices. Kolab is a microservice architecture, and it has always been, although we have sharpened that even more. This is a diagram that breaks it down for the container story of Kolab. So we work closely with Red Hat to actually bring this into the container ecosystem. And every single box here is a container, which means every single box you can individually deploy, scale, make redundant, secure as well, because between every box here, I mean, you can introduce control points. So you have a system that can very flexibly adapt to any kind of load scenario. You can monitor this very, very well, and typically we ourselves do this with Nagios and Munin, so we use the standard ways of monitoring. We orchestrate in a typical scenario with Puppet, based on mostly KVM, but we can run on VMware or whatever, I mean, whatever have you. I mean, obviously you don't want to configure that set of containers by hand, right? So you need some sort of orchestration. You can basically use everything, because the way we have done this, the way we have put together the system, is we have taken where they existed actual standard components and worked with those communities to make those components do what we needed them to do, but gotten all of that always done into the upstream, and have then managed to put it all together, but again, purely by using open standards. So the boxes that need to talk to each other only and exclusively through open standards that are network capable and that can be secured on the network. So if you deploy something like this in a cloud-based scenario, right, where every single thing lives in its own VM or its own container or whatever, and has to talk to its peers through a networking scenario, they can all live in their own virtual network, in their own VLAN, which you can secure individually, and they all do so through PFS if you want. So the full, you know, best possible level of SSL security that you can enable today. So even a network sniffer in the data center gives you next to nothing. You do not get to the payload, and that's by design. What is unique about Kolab, and for some people strange when they see it first, is the fact that we use IMAP heavily. In fact, our user data storage lives in this box exclusively. Everything else, I mean, okay, so this part you also want to secure, obviously, but in terms of payload in the system, these two need to survive. Everything else can burn. What we've done is we've used IMAP conceptually as of 2003 as a NoSQL database, because IMAP translates, at least traditionally, to files on disk, right? And files on disk can scale really, really well. Of course, now we're looking at object level storage in the back and all these kind of things, but the point is, you can scale IMAP to very, very large deployments, and what we've done is we've used the RFC 5464 metadata standard to then tag folders as calendars or address books, as task lists, and this way we can actually get the same level of scalability that you can get out of IMAP for all object types, and we can use IMAP ACLs to map the actual user permissions, which gives you a large range of actual proper discretionary access control across all object types, and actually makes it very robust as well, because your IMAP server ACLs need to work in any case. You need to make those robust. You can split that into front ends and back ends, of course, and you have a directory service for the user administration, right? So that's where the user information lives and where the authentication lives. Those two, if you back up those two, you're good in Kolab. After that, everything else is allowed to be torn down and rebuilt up. You also gain quite a few other advantages, by the way. When you scale on IMAP, nice side effect, you can use any backup system in the world, because, I mean, a backup system that does not do files on disk, I'm not sure that that would really have a huge market penetration, so I will go out there and say you will be able to back it up with whatever you're using. And secondly, so the SQL-based solutions have the huge disadvantage that SQL backup and restore is a really heavy and costly operation, right? And very often you just have to restore the whole damn thing and then try to snatch the objects that you actually are interested in. With Kolab, not so. You just pick the object that you're actually interested in, no matter when it was in your system, and you restore that into the right folder, and you say, here you go. The object is back. You can do object granular backup and restore. And you don't need the backup as often as you do with other solutions either, because IMAP has a feature called delayed expunge, and delayed expunge says, I can actually tag this as deleted, but not throw it away for a certain period of time. And that certain period of time we would typically advocate should be something like twice your level 0 backup plus 1 day. So even if one level 0 backup fails, you still are guaranteed that everything that ever was in your system is in one of your backups. And then it just disappears from the disk at that point. But the very largest amount of backup requests in IT administration is not, I need something from 5 years ago. It is, oops, I deleted accidentally a message I shouldn't have deleted. It's, I deleted a calendar event yesterday and I now realize I shouldn't have. Can you bring that back? Kolab can without even needing the backup. All we do is we set it undeleted. We take the object that's still there and say undelete. There you have it. So IT administrators actually really like this because it makes their life a lot faster and easier, and the backup systems with their heavy tapes and typically slow operation, because I mean they're built for certain specs, right? Do not get needed. And then of course, I mean, you have your whole farm of web-facing services, including a web admin. So we have an API here in the server that allows you to configure the server. It's a RESTful API, so it's essentially JSON over HTTP. That allows you to say, I need a new domain, I need a new user, I want to change users, these kind of things. And we have an admin interface that actually exposes this as a skinnable, themable web interface that uses effective rights to tell you what you can actually do, which says that, you know, this user can change things here, that user can edit that tree, and only what you can actually do is exposed. So you don't see what you cannot do. And it's a self-generating interface in that way. You have a bunch of middleware components here. You have a message bus, which is in particular important for this component here. So we have a full audit trail e-discovery system in there that can, down to the level of user interactions, say what happened in your system. So, I mean, at the trivial level, it is something like user A thinks the system is malfunctioning because an event they put into a calendar disappeared. It sounds stupid, but it's a very common case, because what happened is they put an event in there, their colleague saw it in the shared calendar, said that doesn't belong in there, I'm going to delete it. And they think it's a system malfunction when it's actually their colleague deleting it, right? So now we have an actual audit trail that tells us what happened and can even expose this as a change log to calendars and to events in the web interface. So you can query and say what happened here. You get a change history of that event. You see who edited it, what changes they made, where they moved it, and so on and so forth. But you can also go much, much deeper, right? This goes all the way to the whole question of how do I do full e-discovery in my system. It can ultimately, if you want to set up a Kolab system to do that, and in highly regulated environments you might want to, you can even document who opened which email at which time. All these things you can fully track. And sometimes in some environments that is in fact even necessary. And then of course, the big one for us, and the reason why I'm here is, I mean, we have partnered with Zential to bring MAPI to the server side as one of those little boxes. You will then be able to actually deploy OpenChange. The integration is very far advanced at this point. So you have a full extended MAPI server side with support from Zential and Kolab as your solution around that, in order to have the full stack and the ability to then natively hook your Outlook environment into a Kolab grouper system. So you have the whole Kolab collaboration suite on the server side with your native Outlooks and all the other platform stories that come with that. So this is my quick overview in terms of, you know, where does this solution live in terms of its functional capabilities. So we do all of this as I said, as open standards, open source across all platforms, very, very important for us. And of course, web is a very important one of those as well. We offer this very often to governments, large entities that want to run this. There's a Fortune 50 running Kolab as well. And there, in fact, I mean, normally we do exchange, which, you know, that's what we've done most of the time. But in that particular case, we're actually running parallel to exchange, including, say, a FreeBSI exchange between exchange and Kolab. So the users in the exchange system see the FreeBSI status of the users in the Kolab system and vice versa. So we don't always exchange, just mostly. And we have this as a offering for application and service providers who can run this as a fully scalable, multi-tenant, multi-product solution that can allow them to scale out of one environment for different kinds of products that you can define, because every single capability in Kolab can be linked to, technically speaking, an LDAP role. So you can actually regulate what users can do, and it is self-enforced in the system simply by assigning or stripping roles from the user, which makes it very lightweight to administer and to use for invoicing and billing and so on and so forth. We also have a module for that you can use. But effectively, it becomes a very trivial task, and you get the scalability benefit out of the entire environment across all the users, no matter which product boxing they might have purchased. And then, of course, we offer this ourselves. So Kolab Now is our service. That's our cloud. It's not quite as big as Azure, obviously. This is actually us using an exclusively Swiss-held data center with our own cage, so only we have physical access, our own hardware. So, you know, we actually own the hardware and the platform and control it. We use a fully free software stack with our solution run on top, 2 best practices, and that is what you can use if you just want a small amount. You know, we have SMEs in there, some law firms are using it, a lot of journalists are using it worldwide to communicate with their sources, because they get the benefit of Swiss privacy law, because the data center and Kolab systems both have no ties to Five Eyes, which in today's world is actually beneficial. At least for some professions, it's become quite the selling point. And we give the same solution as Kolab Enterprise, so that's our, you know, enterprise product you install yourself on-premise as an ASP, ISP, and so you can actually run it yourself with support from us. And if you want even twice daily security updates and so on and so forth, we have a very fast response on that. In fact, we were among the first to actually have the full response to Heartbleed out. It came out night from Sunday to Monday, if I remember correctly, from a European perspective. So we rolled new SSL packages because we enable all the strong ciphers that sometimes cannot be exported due to patent restrictions in the US. And we've done the packages, we've pushed out the errata, we've already told our customers to please rotate their ciphers as well and their keys on the actual servers, because we did not trust that it was not possible to actually get the keys, so we said better safe than sorry. We had done that on our own installation, pushed out the errata, you know, updated some managed installations where we help our customers maintain their installations, and then went for a relaxed lunch on Monday and watched as the whole thing unfolded. So we take that part very serious. And the other part that is very, very serious and important for us is upstream. Now, upstream is a term that perhaps the Microsoft people in this room are not yet fully familiar with. I hope you will become fully familiar with this, though, because upstream is where open source happens, where free software lives. You always want to go to the upstream. The upstream is where you have the most useful, in all ways of the world, engagement point with free software and with open source. Red Hat lives there, we live there. Others have drifted from it and now are struggling to get back there. I mean, Google, for instance, has found out that it's way too costly for them to maintain their own fork of the Linux kernel. So they are trying to push everything back upstream and somehow, you know, swim against the stream to get there. And so upstream is where it happens. And that's also where Kolab Systems excels. We have the upstream for quite a few activities. So we are very involved in the upstream of, say, Cyrus IMAP, right? The release manager actually is our architect. We are involved in the upstream of KDE very actively. We are involved in quite a few other upstreams. In fact, we also have been involved in the upstream of what has become Red Hat's orchestration and containerization and orchestration things through Fedora, where we are very active. And we also are the upstream for the webmail application that is known as Roundcube, right? Which is, with more than 500,000 installations out there, clearly the #1 in terms of these kind of applications deployed. It's extremely user-friendly, extremely popular, and the two primary developers on Roundcube have been working for Kolab Systems for several years. In fact, they're even shareholders at Kolab Systems. They have shares in the company, and we work with them extensively because their work has allowed many people to work fully on the web. And that's, in fact, also what we're now doing, and that's the last slide, so then I'm done. We're now calling to the wider community of companies and individuals who have an interest in that technology to work with us, because while we have pushed Roundcube and developed it for many to use, we also feel that there is a way to improve the engagement with all these various companies that are using it already and make the solution that is 100% free software, 100% open source, open standards, that is fully responsive, fully HTML5, fully offline capable as well, and build the application that can enable us to have that heterogeneous network. It should be fully white label capable as well, so everyone can adjust it to their own brands. We want to create the generic tool that actually allows us to have that application that can fully compete with anything else out there, and in fact even bypass it. And we're very happy to see the take-up of this. We announced this a week ago at the Kolab Summit in The Hague. And we've had Tucos and cPanel come on board to work with us on this, and in fact join also the advisory group for making this happen. And I hope that many more of you will do the same. I hope that Xantial itself will also maybe come on board, because we all need that next generation of technology, and I think we can build it better together than we can do it alone. And with that, I thank you very much.
Are there any questions?
Hello. I wanted to know in the slide with all your modules, if you are going to integrate also the chat or instant messages module like Jabber or something like that.
Actually, if you have a look, I'll just quickly go back here. This is it's not fully faded in yet because that's under development. But yes, I mean obviously the whole presence, text, voice, and video chat are the next interesting applications to add. So after we have nailed the asynchronous forms of communication, we are also now going for the synchronous ones, because that's obviously what people want and need and should have. So yes.
I have a question. It's related to the slide you showed. So your goal is very bold, is very brave. You have so many microservices integrating the solution, and you intend to support many different platforms, and you actually offer them professional support to all of them. This is a challenge, I guess, because, for example, if you update the version of one of those of microservices, you need to do a thorough test of everything, and whenever there's a new platform, you need to test it very carefully. So how do you manage, how do you solve that challenge?
That's a very good question. Indeed, that's actually a very big challenge for any tech company, actually. I mean, it's not an easy problem to solve. So what we do development-wise, we've now switched, in fact, to Fabricator internally for our workflow, because we're using increasingly continuous integration in order to actually test every single component that comes in, right? Test-driven development. We're using Scrum methodology internally. then have the ability to actually test that and then run that in automated tests against each other. The other part that helps us is we are not, so we know how to do web and we have very good web developers, but our architect is not a web guy. And so if you look at the way technology works in the web today is you need, so there's no API stability, right, between the libraries. They just change their APIs wildly, so you need that version of the library for it to work, and effectively you always deploy the entire stack. Now Kolab has done that in the past when we did this open PKG packaging, and so we know how painful that can be, especially once things get a little bit more complex. So we've deliberately broken it down to the actual open standards, which means we can go with an API stability that allows us to have more robustness in there. But yes, I mean, for the enterprise version in particular, we're for that reason very, very careful in what we introduce. I mean, the promise for the development version, for the community version, is very clear. Half-yearly release cycles, you know, features first, you know, everything moves fast. And if you want to run with the herd, you know, fine, you know, you can run with the crowd. But you need to be willing to update about at least once a year, typically more than that. And you need to be willing to accept that maybe if you update, your system may not be 100% functional at that point in time, because when developers develop, things break. That's just how it is. You cannot touch the code without breaking the code occasionally. Which is why we do the enterprise version, and that is where we guarantee 5-year support, right? You have a 5-year stability, no breaking updates, and you always have an upgrade path as well. So we guarantee you that you can upgrade from that version to any of the future versions, and we will make sure that your system does not break. Your productivity will not suffer from this, and we support you in that process. So you know you don't have to do this more than once every 5 years if you don't want to. If you want to stretch it another year or so, we can talk. I mean, we find solutions, but it gives you a stable window where you could just get security updates, you know, very minor feature updates maybe, but only if they can be introduced without breaking anything, and then we need to test it very thoroughly. But otherwise, you have a very nice and stable platform, which is exactly what you want in the enterprise.
Okay, thank you very much.
Thank you.